Hi, Robert. Hi, everybody. Hope you're having a good show there in Las Vegas. Got to say, Vegas was always kind of one of the major milestones, as you may know, CES shows and whatnot. And I understand this. You're doing the TED this year, the Plus 4 C116, C16, C232, C364. I missed one? 264. Said 116, right? And you know how I feel about that. If you've seen some of the other videos, I kind of liked the series, but without Mr. Jack Tramiel there, once he left, the series kind of sat out on the front doorstep like a crying baby in a basket, and nobody knew what to do with it. So they thought they'd turn it into something that looked like a C64, and that's how the C16 was made. Now you know the whole story. So other than that, I got a different computer to show you, and it's the LCD computer. And the story of the LCD was when we were done with the Plus 4 stuff, we started the LCD, and basically what happens is the project team's disbanded. You go off and do little things. There's maintenance, things you do. You clean up some schematics or fix a design for production or something, and then you start to. It's kind of like a stellar nursery. You kind of start to coalesce into projects, and as management goes, oh, look at that, I can get a bonus if we do that. And he takes it, shows his boss, and his boss goes, well, I could get a really big bonus if we do, and so on and so on. And so once you get to certain milestones, you add people to your team, you get to have double the number of pencils, all kinds of things happen as you kind of grow into that. So I was originally working on the LCD machine. This one came from the top also, obviously, because we owned an LCD glass company, so somebody was thinking ahead. The glass company was Eagle Pitcher, and we were the only people in America that had, we were the only glass manufacturer in America. Everything else came from overseas, and I'll tell you, back then the glass itself, the LCD panel part was, I believe it was pretty much one manufacturer back then. So, but we had a jump, typical Commodore jump. Other people are, using 6845 Motorola graphics display processors. We're making VIC chips. We're making SID chips, So we're making LCD panels ourselves, and we were going to make we actually did the controller as a gate array, and I don't know why, because I was off by then, but we'll talk about that a second here. So I was on the LCD computer, and we were looking for people to join us. Particularly, we had known we wanted a modem built in. There was a Silent 700 sat off in the office every day. Turns out we were being charged like $2,000 a month for that thing, and it turns out it goes all the way back to the days of Chuck Peddle. We'd been getting charged for that. It never showed up because it wasn't capital equipment investment. It was just an expense. So they didn't. Here's a Silent 700. It paid for itself like 28 billion times. So, but we wanted a modem in there, and we hired Jack Porter, who came out of AT&T in Indianapolis, and I'm from Indiana, and he didn't have an Indiana accent, so I don't know how he pulled that off. But so Jeff really knew modems. He also knew the FCC requirements, whether it's FCC Part 68, Part J, or whatever it is, I've forgotten, but it's for telephone equipment to touch the telephone lines. So real quick, it became obvious that we both weren't needed on the same project. I mean, Jeff was a rock star, and in Commodore, when you get something like that, you turn them loose as fast as you can. They returned me loose on something else is what happened. And that's when Freddie Bowen and me hooked up for the C128, or whatever it's called at the time. We renamed it C128 when we decided to do the 64 thing. So at that point, I had done the initial design of the LCD, including the MMU, and this is where I put a lot of my time in, was the MMU, because I wanted to speed some things up where the editor in the LCD, I wanted it to not be a piece of memory and you move what you're editing to it and then move it back, because at 1 megahertz you could see it go. It was kind of slow. So what I wanted was the editor to just be a pointer into memory, and so you see it as it sits in memory, and so that was the goal. And it wasn't till after everything's done, we're past CES, and I said something about that, and they said, no, we didn't do it. And I said, what? That's kind of, why didn't you do it? And he said, well, they wanted the 25th line, we called it, the function key line, and it's how we do today. We still number the function keys by putting text right. and so that wouldn't have been able to be put in memory. Well, I'm like, well, you grab the chip designer, you shake him real hard, and you say, I'm going to give you another register that points to another place in memory, and you go fetch the 25th line separately. They didn't do that, and the chip designer did what he wanted to do, and at the end, the programmers paid the price of having to shuffle the memory there, and the user would have paid the price of having a little more delay than they would have. So that's kind of the story behind it. So I took the MMU with me onto the 128, and that's where all the banking and stuff comes from. So if we take a look here, all right, so here's the LCD computer. Now this plastic is not ABS. This is a real hard plastic, and this is from what we call a soft tool. So this case is probably a $15,000 or $20,000 case. It's got very cheap Scotch tape that's 35 years old holding it together, and this is how we powered it up. My unit's from the lab, and I am missing the battery door. The keyboard, the keypad, is really nice. This keypad is really nice. It's made by Mitsumi, and what it is, this is not very tall. It's beveled really hard, and it gives the illusion that they're taller than they are, but this is a short throw key, and it's got a real nice key click to it. So this was a first in my book of things to come. Real positive key click. Where in the Commodore 64, you remember those big black tower-ish tall keys. These are real nice and flat, and you can see we've got graphic symbols written on top of them and stuff. Let's go. All right, so and the power switch is here on the side. On the right, we have a barcode plug, line and phone, 6-volt DC, acoustic coupler connector, modem and printer, and you see there's DTE, DCE, jumper settings here. So remember that whole DCE, DTR thing? Well, we had it so you could change it. RS-232 port, Centronics port, serial port, reset button. Hey, everybody likes a reset button. Expansion port. This is a master reset, actually. Here's another reset. I assume it deals more with the expansion connector, and a contrast control. So a lot of controls specific to the LCD that we hadn't seen at Commodore before. So also the size was nice and for back then. Oh, yes, and here's our cursor keys as actual little arrow-shaped keys. I wish I could remember where that came from, because I just know there's a story behind it. I just can't remember the story. This is a memory board, and if you can see it, it's back in the days when we still had solder underneath the solder mask, so everything's wrinkled. But this is just big old bulky static RAMs and EEPROMs, a bunch of EEPROM sockets here, and then this socket was meant to be accessible through the top drawer, and it's got special socket that you can put ROMs in there easier. It's a side wiper socket. So here's our motherboard. By the way, I have 3 pages of the schematic, and I don't have the 4th page. And I've even asked Jeff Porter if he's got one. I don't know if he's had time to look for it, but so I don't have the full picture of what's here. We do have some old Panasonic NiCad batteries, kind of a first for Commodore. Here's the circuitry for the telephone. So you'll see your standard caps, suppression cap, and the coupling transformer. Little DIN connectors. Here's so the DTE DC thing were switches. This is the voltage DC to DC converter, and we didn't really come across these back then very much. So this is how Jeff got all his various voltages. All right, moving on. We've standard ferrite beads, a real tight grid on the ground plane. That's a kind of different style. I'd be interested to see how that does as far as having a low inductance, given that it's as much air as not. But that's very interesting looking. I kind of like that. So if I just go around pointing at parts here real quick, here I've got the gate array for the LCD. It says R0 in it. I'm sure it's hand bonded because the lid's hand glued on, it looks like. A 6510 processor, 6522 IO piece. And I'm looking to see if these things aren't even CMOS. This one's CMOS. I don't think that one is. So, DC to DC converter. We've even got a fuse. Our DTE, DCE switches that I was showing you earlier. Our phone area. NiCad batteries. Lots of analog. This thing actually had a switch on and off its battery power. I think that's a 6510 there, but you know what? I'm not going to swear anything here because I didn't realize there was two hand bonded chips, but they are definitely hand bonded. This one is this is 5707 and this is a 5706. If I had to guess, I'd say they're probably both gate arrays, metal mass gate arrays from not Kyocera. I'll think of it later. Not Hitachi. Got an EEPROM 6522. There's your 6551 UART. NiCad battery, your modem stuff. This is your DC-DC converter, kind of an early one compared to what they make now. And just, you know, the regular kind of glue, some analog. I'm sure there's a reset circuit in here. They had a control turning power on and off, so it could do something similar to sleeping. And that's about it. So now this I had to, when I opened it, the bottom was full of rust. And I had to attack it chemically to clean it up, and it is cleaned up. And oh, actually, yellow wires from me working. So you can so the inside of the case, there's the rust stains, and this is, I was able to get the board this clean, and you see a fair number of jumpers. Again, this is a lab one. This would have been used by Ian or Jeff to get it working. The piezoelectric disc that normally is soldered in here is put away just because it was hanging loose. I didn't like that. And that's what an LCD machine looks like on the inside. Alright, so I understand we'd like to plug it in and maybe see it operate. It'll be the first time in, 35 years. So I'm going to get the power here applied. They put the jumpers on. And then here we go, 3, 2, 1.